All right, this is part 3 of section 5.1. We are going to change the square root of 192. That's the same thing as 64 times 3. Okay, and then we can change that to the square root of 64 times the square root of 3 all over 8. The square root of 64 is just 8. And then I can take out a 4 in the top, and I'm left with 3 plus or minus 2 square root of 3 all over 8. Take a 4 out here, take a 4 out here, I'm left with 2. Okay, so x is equal to 3 plus or minus 2 square root of 3 over 2. Okay, so for our x-intercept, we have two answers for that. So we've got x is equal to 3 plus 2 square root of 3 over 2. And we have x is equal to 3 minus 2 square root of 3 over 2. Now if we look at the y-intercept, that's the same thing as saying x is equal to 0. So in my function, wherever I see an x value, I'm just going to replace that with a 0. Now notice this function goes to 0, or term, and this term also goes to 0, so I'm left with negative 3. Now if I wanted to put these in ordered pairs, this one would be 3 plus 2 square root of 3 over 2, comma 0. This one would be 3 minus 2 square root of 3 over 2, comma 0. And this one would be 0, comma negative 3. Now let's look at this one right here. We're going to find the x and y-intercept. So we'll do x-intercept, which means y is equal to 0. So 0 is equal to x plus 1 squared minus 3. I'm going to solve for x, so I'm going to move 3 over. And then to get rid of the square, I'm going to square root. Now when you place a square root, also add plus or minus over here. It doesn't matter over here because they're going to cancel out. So plus or minus square root of 3, x plus 1, subtract the 1 from both sides. So x equals plus or minus the square root of 3 minus 1. So we have two answers for x-intercept as well. Okay, so we have x is equal to square root of 3 minus 1, and x is equal to negative square root of 3 minus 1. Now if we look at the y-intercept, that means x is equal to 0. So wherever I find an x value, I'm going to replace that with a 0. Okay, so that will be 1 squared minus 3. That will be 1 minus 3. That will be negative 2. Okay, so if we are going to put these into order pairs, this would be square root of 3 minus 1, comma 0. This one would be negative square root of 3 minus 1, comma 0. And this one would be 0, comma negative 2. Now let's look at the general and standard form of quadratic functions, which we already talked about. We know general form is ax squared plus bx plus c with a not being equal to 0. And standard form is a times x minus h squared plus k. So we're going to try to change from one form to the other. So here we have general form. We're trying to change it to standard form. So what I'm going to do is I'm going to find the vertex. So this is 1, negative 12, and 36. H equals negative b over 2a. So negative negative 12 over 2 times 1. So 12 over 2, jumped ahead of myself, is 6. K would be f of 6, so that'd be 6 squared minus 12 times 6 plus 36. So 6 times 6 is 36, minus 12 times 6 is 72, plus 36. 36 plus 36 is 72. minus 72, or 0. So that means that the vertex is 6, 0. Okay, so let's get rid of all this. Okay, so now I can write this as x minus our h value, which is 6, squared, plus 0. So really this is x minus 6 squared. So this would be our standard form answer right there. Now let's do, say that all of these were multiplied by a 2. Then what we would do is we would factor out that 2 if that was the beginning of our function. And then what we would do is we would find the vertex for this right here, which we would come up to be 6 and 0 again. So how we would write that as standard form, we would take that 2, put it on the outside here, and they would have x minus 6 squared plus 0. So 2 times x minus 6, squared. So that would be the standard form for this function right here. So that's what you do if you have to factor out a number, or if you can factor out a number, that number will go on the outside right there. Now let's look at this one. We're trying to take standard form and turn it into general form. So what we're going to do is we're going to first, let's take a look at this right here. We need to expand that out. So it's like x plus 2 multiplied times itself. So we're going to look at x times x and then times 2. And then take this 2 and multiply it times x, multiply it times the 2, distribute that x and the 2. So x times x is x squared, x times 2 is 2x, 2 times x is 2x, and 2 times 2 is 4. So this will be x squared plus 4x plus 4. So then I have 3 times x squared plus 4x plus 4 minus 9. So then I need to take this 3 and distribute to this x squared, this 4x, and this 4. So 3x squared plus 12x plus 12 minus 9. So 3x squared plus 12x plus 3. This would be our general form of this function right here that's in standard form. Okay, let's look at this one. Same thing. What we're going to do is we're going to look at x minus 4 squared first, and we're going to expand that out. Okay, so x times this x and this negative 4, and then negative 4 times this x and this negative 4. So x times x is x squared, x times negative 4 is negative 4x. Negative 4 times x is negative 4x, and negative 4 times negative 4 is positive 16. So we have x squared minus 8x plus 16. Okay, so that whole thing minus 1. So x squared minus 8x, 16 minus 1, so plus 15. So this would be the general form for this function in standard form. And now let's look at the graphs of quadratic functions, and we're going to try to use transformations. If we need to use a t-table, we will also do that as well. Okay, so look at this graph, and we're trying to try to find an equation for the graph that's given right here. So y equals x squared, that would start at the origin right here, and it would go up something like this. Okay, now this has moved over to the right by 2 units and down by 3 units. Okay, so what we have is y is equal to x. If it went to the right, it's going to be negative 2. And if it went down, that's going to be negative 3. Now I need to check to make sure I don't have any type of stretching or compression, which means if I do, I would have a number right outside here. So in order for me to check that, I'm going to create a t-table. And I'm going to use, the graph is going, looks like what we're showing is between -1 and 5. So we'll look at -1, 0, 1, and 2. So the function that we have so far is this one right here. And we're going to see if it lines up with the graph that's on there. Okay, so if I plug in, if I plug in -1 into this function, then what I would get is a 6. If I plug in 0 into that function, I would get 1. If I plug 1 in to the function that we have there, I would get -2. And then if we plug in 2 into that function, what we should get is -3. Okay, so I'm going to plot this over here and see if it matches up with the graph that we have. So -1, 6, that kind of goes off of our graph. That'd be somewhere up here, which it looks like it does. 0, 1, okay, it hits the mark there. 1, -2, hey, hits the mark right there. And 2, -3, it hits the mark there. Okay, so there's no stretching or compressing in this graph. So that means that this is our function or equation for this graph right here. Now let's look at this one right here. Notice, number one, it's going the opposite way. It's going downward instead of upward. So that means we'll have a negative in front. Okay, and then it moved. Let's see, looks like it moved over 1 unit to the left, and it moved up 2 units. So it looks like we would have x plus 1 plus 2. So remember, if you go to the left, you're adding 1. If you go to the right, you're subtracting. And if you go up, that's adding. If you go down, that is subtracting. Now let's check to make sure that we don't have any stretching or compressing. Okay, so I'm going to have a t-table here. Looks like we can use -2, -1, 0, and 1. Because that's where my graph hits. Looks like you could use -3, but that's a little close. And we might not be able to use 1. It might go off our chart here. Okay, so I'm going to plug in the values of x into this function that I have right here. Okay, so if we plug in -2, we get a 1. If we plug in -1, what we will get is a 2. If we plug in 0, what we will get is a 1. And we'll go ahead and plug in 1 and see what we get. So if we plug in 1, what we will get when we plug into that formula is a -2. Now let's see if that hits the marks. So -2, 1, -1, 2, 0, 1. Okay, so it looks like it's not hitting the marks. And then 1, -2, so that would be out here. Okay, so it looks like we either have some stretching or compressing going on. Okay, so what I'm going to do is I'm going to get rid of this table. So I know that I need a stretching or compressing factor. Now what I'm going to do is I know that, so there should be a number. We don't know what that is. We'll say A. There should be a number right in front of there. So I'm going to choose a nice point on this graph, say this one right here, that has the coordinate pair of -2, -1. I'm going to substitute that into this function here and try to find out what A should be. Oh, x is now -2 plus 1 squared plus 2. -1 equals -a. That's -1 squared plus 2. So that's 1. So we got